today. So this, just so you're fair warning, and I see some folks have put in their note-taking scribes. I'm fine with it since we're going to be recording anyway. If anybody has an issue with that, please let us know, and we can kick the scribes out. But so anyway, we'll be recording, and this will all be sort of public record stuff. So a bit more about how we'll spend the time today. So yeah, I'm welcoming you. We'll take a deeper dive into interoperability. What do we mean by interoperability? Why do we need it? How do we build it? And I'm really happy to be joined today by an array of experts, starting with my colleague, emeritus researcher now from Alliance Biodiversity CIAT, Elizabeth Arno, who's led a ton of our ontologies work in our Agriculture Research Institute and our global consortium, CGIAR, followed by Phil Archer, Web Solutions Director from GS1 Global Office, Branimir Rakic, Chief Technology Officer of Origin Trail, will give us an overview of their approach to decentralized knowledge graphs, and Christian Hennig, CEO of Perma Robotics, and also an active participant, or perhaps even leading some aspects of, or perhaps both, of the International Standards Organization group on working through standards for smart farming. I put sort of oddball times in here because I've given everybody 14 minutes or less. I want to make sure that we have plenty of time for questions, and please feel free to put them directly into the chat, and John and I will kind of tag team as monitors of the chat and facilitators of the discussion. And so with that, I'll hand off to John. And I guess maybe I should run the slides for you, John? Or would you prefer to do it yourself?
No, that's fine. So just as by way of introduction, so you'll see here at the top as Traceability and Governance Work Group, and this is the phase 1 report. You can get access to that. This is not about Brian or I, this is about the brain trust that we have collected over last year and the start of this year, and also now with phase 2, which will be 5 webinars, and Brian will show those in just a couple of moments. But just by way of introduction, for those who are on the call today who are unfamiliar with the complexities or the nuances around interoperability, we have 4 common terms. We talk about semantic interoperability, which is really, it's about meaning; syntactic, which is about format; technical, which is about connecting, essentially. And then we have the organizational interoperability, which is about the governance component. And what we're trying to do over the 5 webinars is hit those from different angles, different lenses, different viewpoints. So interoperability obviously is critical for the seamless integration and exchange of data to support the EUDR program. And of course, if we don't have interoperability, we're going to have data loss, and we may have issues with market access and so on. So there's a lot we could say about it. What I would encourage you to do is to look at the report that we've published. Brian, if you want to put it back up again so people can scan the code on that. Go back 1 slide. And it's quite a rich report. It's more of a technical report, and your feedback on that is obviously important. We're going to be building on this report to come out with phase 2 recommendations. Right? Yeah, so from the 5 webinar series, if anyone is interested, we do have a slide that represents each of these in more detail. But just at the high level for today, we'll be talking about the semantic and syntactic interoperability. Our next session will be on EUDR compliance in action. So here we're looking at practical traceability scenarios. We're going to skip next week, but in the following week of the 22nd, Tuesday 22nd, we're going to have 3 companies that have active solutions who are actively engaged in delivering EUDR solutions. One of those is a Canadian company that's exporting soy from the US into Europe. Now, one of the things that I just want to point out here is we're looking at evolving our understanding of the different scenarios or use cases involved in EUDR. So for example, beef that comes from Brazil that goes to the EU and is consumed in the EU is a simple use case with two countries. But if those cattle in Brazil consumed soy that came from Colombia, then it becomes more complex. And if that product is exported to the EU and part of it is consumed in the EU, part of it is further processed and then exported out of the EU, you can see that the use cases start to evolve. And there's multiple use cases, maybe 5 or 6 that we want to touch by the end of May if we can. As I mentioned, our role is also in governance, so we'll bring in some experts on governance and stakeholder roles in interoperability and talk about what are the roles and responsibilities, how do organizations interoperate with regard to supply chains. Brian, yeah. And then we'll look at innovation in traceability. No, back again, Brian. You're going too fast here. Go back one. Yeah, we look at innovation and traceability and look at what's happening out there. So for example, we have some examples of open source solutions, but we'll also look at privacy and trust preserving solutions. And we'll look at overall supply chain integrity and how is that maintained. In this session, we will have a solution provider that will do a deep dive, a 30-minute walkthrough of their solution. And this is a company called Trusty.io from Italy, and they will show us in great detail how the solution actually works, and we'll talk through the different use cases as well. Then the final one, we're looking for experts to bring together and say, how do we future-proof our supply chains and how do we build this roadmap for EUDR compliance? And that'll be on the 13th of May. Okay, Brian. I wanted to flash this eye chart for you. We created this based on old work from about a decade ago, or a little bit more than a decade ago, that started off in GS1 as a very simple chart with primarily the center component around traceability. What I do want to remind people who are on the call here is that traceability is both the track and the trace. So you track forward and you trace backwards, and often we mix up those. But in context of a lot of supply chains, and especially EUDR, we can also break out and talk a little bit more about authentication and verification. Now, many people have opinions on these words and whether the appropriateness of these words in here, and they put some nuances on it. But for now, this is a snapshot in time. When we talk about authentication on the left here, we're talking about object and location identity. So object authenticity, does the object scientifically verifiable characteristics match what it's claimed? So in other words, it's not just the physical product going through the supply chain, but does it have the characteristics of that piece of land that it actually came from? And over here on the right-hand side is where we would also have components of that credence claims. The object identity, is the object verifiable? Is the object ID valid? The object origin, is the origin of it, whether it's a GS1, GLN, or it's polygons, how do we know that they're valid and from trusted sources? And then, of course, we have the object security. Does it have the relevant covert, overt, or forensic features that can prove that it's authentic or help in that verification process? If you're talking about large volumes of grain, for example, there may be a forensic taggant placed in the product as well. Now, I'm not going to go through the right-hand side, but I wanted to put this up because this helps us in the discussion, the taking a more broader view of what's necessary. And hopefully this is food for thought for a lot of you experts to look at this and maybe complement this. And Brian and I would love to have your feedback on this. We want to mature this into either a white paper or a formal publication explaining every single aspect of this and how it interoperates as well. Because at the core of this, it's around the interoperability of these key components. Brian? And pass over to you on this one, Brian. You're on mute, Brian.
This group is very rich. And so we often like to know who we have in the room, and it helps us to kind of guide our discussions a little bit, and also know that we aim for a good diversity of view around discussion and insight. And so I'd like to launch a poll while Elizabeth will be up next. If you can start preparing your slides for sharing, and I will launch this poll. It's loading, and there we go. Let's see. Okay, so you should see a poll, or maybe it's making its way to you. Just what's your type of organization? I'm with a research organization, so I will click on research. We're nonprofit, we're public. How many responses have we got? 32 responses. Okay, that's pretty good. It also helps us know who's paying attention. Good. Oh, really interesting. Yeah, we try to aim for a good balance of public and private, like sort of technology providers. And since we're dealing with, some really significant regulatory compliance issues right now, both with the EU deforestation regulation, but sort of in the pipeline already, and in some cases already being implemented, or in effect, other types of responsible supply chain regulations. And so that that framing, that broader framing, conceptual framing in terms of integrity, we think is a helpful way to be able to not only get ready for compliance with EUDR, but to be ready for future compliance issues, and indeed any number of other kinds of shocks or issues that can arise within supply chains, food fraud, trade shocks, and so on. Sort of the ability to manage this towards greater integrity in supply chains vis-a-vis those other challenges. So handing off to you, Elizabeth.
Thank you, Brian. So I will introduce the concept of agri-semantics that covers all the ontologies we have been either using or developing for agriculture and food systems. Then I would like to refer to a workshop we held last year. Brian was part of this workshop. We have been holding this workshop every 2 years with a large community of scientists and developers working around agri-semantics. And the focus last year was about agri-food semantics in the age of artificial intelligence, to understand if such a semantic has a role to play to improve the result of AI. Then we brought 85 participants, and we asked them, speakers or participants, to answer 2 questions. What were their definition of what is AI-ready data and how semantics can help? Then data ready for consumption by AI mainly should have the same quality than for being used by human, and provide interoperability. And the first answer, of course, was that data should be open and comply with the FAIR principles, which are definable, accessible, interoperable, and reusable data, and be of high quality to strengthen any machine learning models. And so for doing such quality, the data should comply to the following list of criteria. So be pre-processed, organized upfront, accurate and consistent, responsibility sourced, so you know where it comes from, the provenance, traceable, standardized and interoperable, machine readable and actionable, contextualized, unambiguous, so no need for translating data, validated, representative of real life, trustworthy and ethical, respecting the care principle, which is covering the community knowledge and data, and representing stakeholders' interests and values with governance. And for all those elements, the role of semantics was highlighted as crucial to reach such a quality level. Then ontologies are representation of human knowledge, as you know, and they provide a semantic relationship between the terms, which will be the labels annotating the data you want to collect, store, and exchange, and they add clear definitions. Then they provide the context of use of the term. And this helps a lot to disambiguate the terms which has multiple meanings. Ontologies enable machine-readable knowledge graph, integrating human knowledge representation and contexts. That's an important point. And it can help, thanks to all those semantic relationships, an AI deductive inference and reasoning, and also can include the stakeholders' interest in the metadata. So large language model need to determine the correct meaning of a term based on the context of the question and data, thereby improving the accuracy of the answer. So really ontologies can be useful to achieve this, and also can help validate the result generated by LLM by checking the answers against the ontological knowledge, correcting them if they deviate from established facts and relationships. And therefore, during the workshop, it was concluded that semantic resources should be embedded into the AI learning process, so at an early stage, but also be used to validate the results. However, there is a challenge. Still, we have been working at addressing that challenge. It's a lot of small communities are developing their vocabularies, and those vocabularies provide different definitions for a single term, or it multiplies the number of synonyms for a single concept. And sometimes it's not properly defined. So to address particularly that challenge, we've been working through many projects in the CGIAR to provide this online graphic summarizing and classifying the reference ontologies. Reference ontologies are ontologies that comply to quality criteria list that was developed by the Committee of Practice of Boundary. So it's really a list of criteria, and this makes sure that reassure the user that the ontology is useful, is applying to a specific domain, and will be maintained over time, which is an important point. So in this schema, you can see all the ontologies we have been compiling, from the genetic data to the species taxonomy, to the environment, agronomy, fisheries, plant, livestock, food nutrition, and socioeconomics. So this is an online schema, so it's still available. And from this schema, I will talk about 4 ontologies I just highlighted for the purpose of this workshop. First, it's the plant phenotype. I decided to take this one because it's one of the topics of interest for the Alliance. And it helps describing the performance of variety in a given environment and the requirements the variety has for growing. Then the agronomy, because it provides all information about how the product is produced and what were the practices in the field. And the third one will be the environment, with the environment ontology that provides concepts around features, environmental features and habitats. And the last one will be food and nutrition. It's a crucial ontology, particularly for food supply chains and food nutrition. So just to give you some details about those 4 ontologies, the first one is about describing a specimen in nature or in the field. the need to collect data in the field is really important to collect those data in a framework. So in fact, for measuring a plant trait, for example, you have 4 ways of doing that. So after, if several teams are measuring these plant traits 4 ways, different 4 ways, it will be difficult to compare the data really and make them interoperable. So we needed a framework that would guide this collect of data, indicating that you need to decide which trait you want to measure, how to measure it, and add a scale and unit, each element having a clear definition. And this development has been led by the need for mainly plant breeders to use digital field books to record their data. So this is an important aspect for agricultural data. The second ontology I just want to highlight is the agronomy ontology and show you how we have been designing the knowledge about the human knowledge about this topic. So an agricultural experiment to test a plant in the field is an experiment that realized as an agronomic experimental design, which is in the case we took a completely randomized design. So the design belongs to the experimental design class here. And the experiment is occurring in a plot or several plots. And to test your plant, you need to apply a treatment. This treatment can be a fertilization process, which will occur physically in the plot and is part of a global treatment of the plant. This fertilization process belongs to the class of agricultural process and is a planned process by the farmer or the researcher. And this fertilization process has one participant, which is the tool, a boom spreader, and the other participant is the fertilizer itself, limestone, which is classified as a sedimentary rock in the environmental ontology, is recognized as having a role of fertilizer. And of course, you need to document or inform about the amount of fertilizer you've been applying in the field and give the unit. So this is just an example of the modelization of the knowledge around agronomic data. The third ontology we've been working with a lot. It's also a large consortium behind this ontology. It's the environment ontology. And here I used an online tool that enables anyone to search for ontological terms. It's developed by the European Bioinformatics Institute. It's called the Ontology Lookup Service. And here I search for deforestation term. And I got 2 terms from the environmental ontology. One, it's deforestation itself with the definition, and the second one is planned deforestation with its definition as well. And each term has a label here in orange, which is a label you can copy and paste for annotating your data into your database or into your files, or you can retrieve automatically this label. So this ontology, so any data annotated with this term can be retrievable and be compared. Here I just added the semantic structure where deforestation is placed under ecosystem process and under the upper class of environmental system process. So the last ontology I wanted to mention is the food ontology, farm to fork. It's also a very large consortium behind this ontology and supported by the institutions that are listed here. So this ontology provides a modelization of the knowledge around food product from the quality of the food product itself, ingredients, for example, but also the processes for transformation, cooking, preservation, treatment, also the packaging, the consumer. So it's quite complete. And on the right side, I added a diagram that was published in the paper referred here. It's about an apple as a food product, raw, so it has a description of the quality. And this apple is semantically linked to all the transformation process it can go through. In that case, it's caramel coated, sliced and canned, cooked, etc. But also on the other side, it's also linked to the element or the specimen it comes from. So the apple develops from an apple tree. And this apple tree has a taxonomic identifier. And what has been done over last years in collaboration with our team, it's to link the food ontology to the agronomy ontology and to the environmental ontology. Therefore, you can semantically progress from the food products back to the tree of origin and understand how the field was conducted and in which environment the tree was growing. So this is an important element. So, and it also exemplifies the fact that all the reference ontologies are specific to a domain, but they are linked in a network of ontologies that enables to annotate a large amount and scope of data addressing the supply chain, for example. So the last point I wanted to make is talk rapidly about the Titan project. It's also an EU project enabling the transparency in food supply chain by implementing innovative digital solutions to boost health, sustainability, and food safety. It enters its third year, and the innovative solutions are based on DNA rapid detection method, blockchain, AI, and IoT. And the idea is to enable the data transparency across the supply chain from the first segment to the consumers. It's led by the European Federation of Food Science and Technology and ILSI Europe. There are 3 modules in which they have regrouped SMEs and startups developing digital innovations. So one is for food safety. So it's also for really detecting allergens, but also food safety, microbiology, and fraud about the type of product. One pilot is for sustainability, pilots for sustainability. So it's all about the first segment for production of the food product, but also the connection with the transaction with retailers, carbon certification, traceability of the labor chain, etc. And the third module is about health. Of course, around those SMEs and startups, you have academic research being conducted to define what are the blocking blocks for the transparency of food supply chains and what are the enabling elements. So it's research on policy, governance, business models, and stakeholders' expectation. So just to summarize rapidly, along the food supply chains, there are digital solutions being developed, and each actor of the segment is the target audience, and each digital solution is tested at the level of the target audience. The idea being that by using the QR code and RFID, the consumers and the customers can access a certain amount of information. One challenge across this exchange of information along the supply chain is some reluctance to share some data from one segment to other segments. That's sometimes difficult to make sure that this information will be open, and also the difficulty for consumers to make some trade-off in their choice, because they have a lot of information about the food product impact and how to choose the food products against deforestation or against drudgery in the labor chain, etc. So those are elements of research for this project they are addressing. And I will just finish with this table just to indicate that this project has already made a summary of all semantics that can be useful for a food supply chain with some criteria of evaluation, and they have indicated that they need to identify also what semantics can be useful for addressing the new European regulation about deforestation and provide this information to the consumer. That's all. Thank you very much for listening.
Fantastic. I think we could do one question while Phil gets poised for following on. So there was a question that came in and it got a thumbs up as well. So I think two people had this question around. Well, first of all, thanking you for showing where to find well-governed reference ontologies relevant to the topic, and then who are the primary users now, and where should we be targeting for uptake and further use?
The primary users of the ontologies I mentioned at the moment it's a lot about first, I would say, research in agriculture and agri-food systems for sure, because as you know, open science requires open data, and then the needs for having readable semantics arise quite rapidly from the genetic side of the research, and now is spreading to other domains of research, as I mentioned, up to economic data. And also other users in needs of those, I would say, structured semantics are people developers of digital solutions, like I said, digital field books. Also all the technology behind the QR codes, the RFIDs, also the blockchain chains. We have been approached by many projects working on those digital devices for finding ways of better annotating the data, have a standard structure of metadata, and make sure that the vocabulary is compliant. That's the type of user we've been approached to. I would say also we've been approached by developers of tools using satellite imagery, where you can also detect land use and land cover. But I may mention that at the moment I didn't found any vocabulary about land use, land cover, or land degradation in environmental ontology. And I'm sure there are other sources for checking the existence of such vocabulary, like the Land Portal. It's a resource for accessing satellite data about this, and they already have some theory of vocabulary around this information.
Brian, before
Fantastic.
you use
Yes.
Phil, just a quick comment. So Elizabeth, thank you for that. It's great to see the summary of that. You just as a lead-in for Phil, you mentioned two things that I think are particularly important to the work that Phil does, and that's the reluctance of organizations to share data, and also the trade-offs that consumers need to make when they're making that decision based on the information that they can access. And I think that's a good intro to what Phil will be talking about. Brian, you want to do the quick intro?
Yeah, I think that's good. I think we see Phil Sly's Web Solutions Director with GS1 Global Office, and one of the things I've been really impressed by my engagements with GS1 is how how applied everything it is that they do, and how very user driven and member driven everything that they do is. And so finding these ways, these very tractable and applied ways to be using semantics and supply chains is clearly a strength that GS1 brings. And I'm looking forward to hearing more from Phil.
Well, thank you, Brian. Thank you, John. It's a real pleasure to be doing an event like this. It takes me right back to the work I was doing up till about 8 years ago when I joined GS1, when I was at W3C. Elizabeth, there certainly are ontologies for describing land use. Years ago, I was pointing out them. I did some EU project work with various people. I forgot because I hadn't had time to look it up because I'm talking to you. There's a European Commission arm based in Italy that does all the land use stuff. They've definitely got ontologies for land use stuff, and it works with all satellite imagery and so on. I've just forgotten what it was. I'm sorry. But listen to what you were saying. It rings so many bells and has so many contact points with my current work and previous work. And what I want to talk about today is this issue about interoperability and how. As Brian said, we have to work in the real world. We work in a world where different people have different ideas about things. Different people have different policies on what they will and won't share, what they will and won't change, what they will and won't do. We've all been to events like this. This is a picture from an event I did years ago. And Peter on the left from Sweden is talking to Andreas on the right from Hungary, and they're chatting about the things they have in common, and they're talking about open data and sharing ontologies. And sooner or later, one of them was going to say to the other, hey, we should align our standards. How many times have you heard somebody say, we should align our standards? What they mean is, hey, you can use mine. Yeah. Or you could use mine. Actually, people don't. Actually, people use their own. And there's a reason for that. There are lots of reasons why people actually want to use their own work. And it's not unnatural, it's not abnormal in any way. Because if you're using an ontology, a vocabulary, a standard, whatever the particular niche is that we're talking about here, it will be the result of lots of work. The amount of months in the work that Elizabeth was just showing is, I'm sure actually it's person years, developing those ontologies, having the agronomist's expertise and the plant science expertise and the food traceability and the food industry expertise to create those rich, detailed ontologies. Takes an enormous amount of work. And that means a lot of investment in those people's time. Often it means investment in the infrastructure. That portal that shows it all nicely working together and how one links to the other, that didn't happen overnight. People worked hard on that to make sure that it actually made it easy for you to use. So there's this very significant investment in terms of people, time, and infrastructure. But beyond that, there's the personal passion. There's the if you work on a project for several years, you want it to succeed. You want other people to use your stuff. You want your work to have meaning and outcomes. So of course you're not going to do what someone else says. Of course you're not going to use the other person's ontology. What's that? This man is challenged to describe this object. Well, if we look at different kinds of things that we might call a spade, you can think about some of those semantic relationships here with these. Because if it's very long and thin, that might be a trenching shovel. Very good for, well, digging trenches. If you want to move something that's slightly more lightweight and move it quickly, you want to use a snow shovel or a trowel to plant that rosemary bush so it doesn't take over the whole garden. Or maybe the spade is just a spade. Those relationships are important, and that kind of expertise Elizabeth was talking about gets encoded into these hopefully well-developed and well-maintained ontologies. And this is ours. This is the ontology that we have. It's called the GS1 Web Vocabulary. It's built as an extension to schema.org. And as the barcode people, you can imagine we have quite a lot to say about products. The number of attributes, a number of properties that we can ascribe to a product is quite extensive, and we can go down to subclasses. There are a couple on the screen there. But here's what I really want to get to in this context today is I don't expect you to use this. I mean, I'm happy if you do. You're very welcome to. It's published in a way that's designed to be easy for you to use, but I don't expect you to. What we do is we map our terms to other people's. In particular, schema.org, which is the world's biggest or rather most used ontology. It's also pretty big. But the schema.org ontology appears on billions of web pages. It's very general purpose. It covers quite a lot of things. And it's also pretty politically neutral. I didn't realize when I started working in standards many years ago that they can be very, very political. And that feeling of you should use my standard can run very deeply. And you can be in a room with someone who has their standard and they don't always get on with you, right? There's an antagonism. But schema.org, run by Google, is pretty much a neutral place and very general. So we have no trouble at all in saying that when we say GS1 product, it's the same as schema.org product. Not just schema.org, this is another one of our classes in our quite big web vocabulary about quantitative value. And again, we don't just map that to schema.org, we also map it to an older vocabulary called the good relations vocabulary. Its exact matches there. But you can see that you could potentially go further than that if you're familiar with SCOS, as I imagine many of you will be. The SCOS semantic relationships allow you to say that my term here is broader than yours or narrower than somebody else's or whatever it may be. And you can declare those semantic relationships in such a way then, exactly as Elizabeth was just saying, you're providing information that the artificial intelligence agents can use. Now, what we do when we publish our vocab, it's very much, as we've seen just before from Elizabeth, other people doing much the same thing. Our vocabulary is published in such a way it's designed to be found and to be easy to use. So if you go to its homepage, you can actually get hold of the original file. All you're seeing here are these screenshots of the browser. But the actual data itself is published as a JSON-LD file and as an RDF turtle file, and it's published at a place that is persistent. It will be there long after I've retired, and if I've done my job properly, long after I'm dead. These things are designed to be there for the very, very long term. The way we publish our things on our repository at ref.gs1.org is everything that has versions. There'll always be a link, a permanent, persistent link to the immutable version. And then there's another link that doesn't have a version number in it, which always goes to the latest version. So it's designed to be used directly by machine processors and published with that persistence and that ease of access in mind. And because we've done that, I should say, yes. And so we believe that this idea of linking from our vocabulary to yours and vice versa is something that we should do, and we want to encourage other people to do. And link to schema.org or some other, take your pick, I don't care. Link to other vocabularies. It makes it easier for machines to provide the right information. And we are certainly willing to do that. And I just looking at that food ontology that Elizabeth was showing, you saw there was a product and lots of links going off it. Wouldn't it be great if you included the barcode number on that product? So scan that and you can potentially get all that lovely information about it. Can those semantic links not be produced by artificial intelligence? Do we actually have to do that work ourselves? Can't we press a button and get ChatGPT to do it for us? No, is the answer. This was, I'm trying very hard not to talk about the individual case here, but we were working with another organization's vocabulary, and we asked, I think it was ChatGPT, if it could map that vocabulary, which was published in an Excel spreadsheet, exactly, with schema.org and the GS1 web vocabulary. The results were not very good. I don't think it got anything right. It may have got the odd one right, but that was like, the exception rather than the rule. Generally, it was absolutely terrible. What we're trying to do is to provide the information so that AI gets it right. So to summarize what I've been trying to say, you can assume that other people are going to use the standards that they worked on, that the vocabularies they worked on, that they developed for their own system. They're not going to use yours any more than you're going to use theirs. But if we use those semantic relationships, we can potentially provide those semantic links between other people's work and our own, which enriches everybody. My work is enriched if I can link it semantically to yours, and I hope the reverse is true. So maybe those traceability vocabularies that Elizabeth was showing, maybe we can access that information, that hugely rich information, by a simple scan on a product. And however else you decide you might link to, perhaps map to schema.org, which, as I say, is the world's most used vocabulary. AI can help, yeah, but don't rely on it. It's hard work. It takes time. Humans have to do it. It's about helping AI to get it right. Thanks for your attention.
Thank you, Phil, for that. It was excellent overview. And I just put in the chat there, if anyone is unfamiliar with the GS1 organization, pop onto the website and you'll see that they're an industry-driven and not-for-profit. And something I always like to point out about GS1 is that if regulations define the what needs to occur, the GS1 standards are then developed by industry to define and determine the how to, typically a lot of implementation guidelines on how to actually physically do stuff. We have about 40 minutes left. Brian is going to introduce our next speaker in just a moment. I would encourage everyone that has any questions to please pop them into the chat, and either Elizabeth or Phil can pick up questions for them specifically, or if you have a generic question about this initiative moving forward, the next workshops, please ask, and Brian and I can address those. So Brian, over to you for the next speaker.
Certainly. Yeah, thank you both. Thank you both. We heard kind of two versions of a story around the need for, we need to have some semantic depth. We need to have some depth of meaning if we expect, certainly if we expect AI systems to help us to, manage data and manage the interoperability of data and systems. We heard kind of a science-led way of going about it, which we absolutely must do, particularly if we look at that integrity framing that we put at the beginning. There are a number of points there where open science, I think, is just fundamental. Certainly scientific research, but I think open science particularly is really fundamental, because you need the ability to not only harmonize in terms of measurements and meaning, but you also need the ability to share data, share methods, have those open to critique. And so we're coming across this right now, for example, with the EU deforestation regulation around any number of quite good technical solutions out there. But until you can go and benchmark them and evaluate them and test them in a comparable way and scientific driven way, it becomes really hard to evaluate and to sort of pick. At the same time, we talked about semantic depth regarding food flows and product information. Again, really unlocking things, making it important to be able to kind of translate across. From the open research and the researcher side, it becomes really important to get subject matter experts more or less on the same page. Because of the precision of definition that you need, and around that, what I consider to be a gold standard, but in some cases maybe we need a silver standard, to tractable ways to be interpreting the world, in ways that there might still be a bit of contention or ability to accommodate differing views. So this is kind of, at least conceptually, where I see the flowing into the presentation from our next speaker, talking about decentralized knowledge graphs, where we can certainly be connecting concepts, and progressively we can integrate the semantic depth into how we go about connecting those concepts. So over to you, Branimir Rakic, Chief Technology Officer of Origin Trail.
Hey everybody, Branimir here. Nice to meet you all, and really excited to be part of this discussion. A lot of stuff was already shared, so I'll try to somehow piggyback on that. And I'm super happy that the community on this call is very much already into the topics that we'll be presenting. So I'll be sharing my screen in a moment. You guys should see a presentation just about now. And I'll try to speak to, and I hope this doesn't bug you, so maybe hide you below. About what the project that I'm one of the co-founders of is about, and how we have been handling semantics in the widest possible sense in a decentralized context. Origin Trail is a project that actually launched over 10 years ago, started as a centralized proprietary closed source product, turned into open source decentralized standard-based product. So I'll try to explain that briefly. And what you get to see today is actually also our new look that just launched with the new website yesterday. So just a very brief intro slide into what we all try to tackle here. But a very brief intro on why Origin Trail. In the grandest vision sense, Origin Trail aims to go into the direction of exactly solving the challenge Phil just said, which is people will be trying to use AI and will be unreliable, especially as it is today. So the grand vision is to reach a safe and reliable artificial intelligence in kind of a sense of the global internet today. And in a very, very simplistic way, we like to start with sharing that our vision actually aligns very much with the metaphor of the human brain. The human brain being left and right-sided, and where the right side is responsible for the creativity. So obviously the creativity can be wrong. So, but you've probably witnessed the latest couple of weeks, we've seen some incredible images of these anime-like characters floating all over the social media, essentially creating something very creative, beautiful, questionable on how useful it is. But absolutely, you cannot deny that Gen AI, the way we see it today, is very creative, which basically comes from a property of it being probabilistic. It does statistical predictions, and it's really good at natural language I/O, but is it good at solving a precise task where you need something really reliable and not so creative, like Phil mentioned? Not so much. That's where we like to rely on the old school symbolic AI that we all know so well, which is really great for facts. So basically it's deterministic. It has all the logical reasoning and inference components that we like when we talk about ontologies and knowledge graphs. And in our world, the way we try to tackle these two is to combine generative AI models, what we have today, and we see will be developing in the future, will be becoming better and better, but fundamentally be on this right side, creative side. So hallucinations being a feature, and this creativity being where it will flourish. And on the left side is what we call the decentralized knowledge graph, which is really a symbiosis of various knowledge graphs into one sort of big symbolic AI engine, ultimately to come to something we like to call collective neurosymbolic AI. So I'll be speaking about that today. I'm trying to dive deeper, and then I'm going to show some examples, but another way to think about this is what kind of qualities we're looking for. So we want to avoid hallucinations. We want to have information provenance, fair value exchange as well, because a lot of that is not happening today on the internet. And whenever we talk about sharing of data, it's always about multiple sources, interoperability as the topic is today. But also in our world, it's very much about data ownership. What does it mean to own data, and how we ensure data privacy, which is all of these are properties that we would like to see. I'll talk about briefly today, but I'll try not to overwhelm you if possible with all of the details. Plenty of it, like I said, again, it's open source, so you can check it out also on our websites. From kind of the highest level, we can think about Origin Trail as a 3-layer neurosymbolic stack. At the bottom, we have this trust layer, which is actually comprised of blockchains. I'm happy I heard about blockchains on this call as well. For a while, they were kind of like the black sheep of the industry, as sort of being shamed in the corner. But they're very, very useful in certain things, not the things that they were initially marketed for, but particularly to provide trusted environment for either simpler executions or identity, such as decentralized identifiers. But ultimately, having this ability to, in a way, tag and fingerprint all of the content on the web into some trusted environments. And Origin Trail, obviously, in this way, thinks about this trust not as one single blockchain, but multiple different blockchains being possible to be used in this trust layer. Why would they be used? Well, in the framework of Origin Trail, we basically look at the minimal usage of blockchains, so not some voodoo type utilization, rather fingerprinting, or rather, better said, timestamping and fingerprinting proofs of knowledge sitting in the second layer of the knowledge base, which is really the decentralized knowledge graph layer. Again, a decentralized network of nodes that each host their pieces of this knowledge graph, either being private information that they own or shared public information. And then for each piece of that knowledge, there's a reference proof on this trust layer below. Ultimately, on top, enabling this ability to, at this moment, provide verifiable AI. So that means that whatever input we give to whatever symbolic or neural symbolic system, it can be coming from the bottom two layers. So a structured piece of knowledge that has been timestamped, signed, fingerprinted on a tamper-proof blockchain. So this is on the highest level. And if I show it in a different way, I can also show you an example. So an example is such a network that we have collectively been building with Swiss Railways and their partners. So this is actually a group of partners, and what you see here on this network is nodes in this network, and this decentralized knowledge graph, or as we call it, a pairnet. So what they do is share railway data, and there's no central authority here. Everybody can just boot up a node. This group lets them into a pairnet, and all of a sudden they can start synchronizing information, and they can start publishing information across the network, and obviously doing federated querying. Naturally, there's a bunch of standards under the hood, including W3C and GS1 standards. And there's actually a lot about this in the webinar. I can share the link later where SBB, Swiss Railways, explains this. But ultimately, they achieve a system where each one of them retains data ownership and privacy, yet again is able to share all of this information with a way that each of the pieces of knowledge, in this case, contain data provenance. What are these pieces of knowledge? Well, we call them knowledge assets. And these knowledge assets are essentially small signed pieces of graph data that, through the signatures and proofs sitting on the blockchain, also attain a uniform asset locator, or UAL, out of which also, obviously, it's very easy to produce vector embeddings in various different scenarios, either in graph neural way or classic way. And so think of these knowledge assets as the units of knowledge that each one of them is timestamped, signed, and owned by somebody, as each one of these pieces has a corresponding NFT on one of these blockchains that allows transferability, monetization, and so forth. Another way to look at this is through the lens of RAG. RAG is all the rage, right? So when you think about where the DKG, the decentralized knowledge graph, can live, it can live in different devices. We actually have a notion of core and edge. So think of edge sitting obviously on edge devices and being able to do RAG on each one of them. So I can, for example, host a node of the DKG on my laptop, and I do, by the way, for building purposes. Or somebody can host a core node, which would be a node that's generally always live and provides access to the public knowledge graph at all times, for which they're incentivized. And these two components play together. Basically, they help the connectivity of the network, ultimately enabling what we call decentralized retrieval augmented generation, so you can query across this entire network. Now, the enablers to actually get us there, obviously touching upon syntactic and semantic interoperability here, are Some of them are your usual suspects. So obviously semantic web standards, but some of them are not so much. These verifiable credentials and the decentralized identifiers, if you haven't ran into them, they are very exciting W3C data models and standards that enable actually authentication of information and decentralized identity capabilities. Very interesting stuff. Obviously GS1 standards. So I'll show you in one of the next slides one example which utilizes GS1 digital link, but also others such as EPCS for event-based tracking. And then as well tokenization standards that are very useful if you think about ownership and how you can implement ownership of pieces of content. In this case, we believe this is incredibly important in today's age where AI as it is today is literally stealing everybody's content, and the intellectual property protections are to be put in place in some obviously naturally decentralized way, as the content on the web is naturally decentralized. Looking at the semantic interoperability enablers, again, some usual suspects, shared ontologies, and schema.org is one that was mentioned previously. We see it heavily used in the DKG. But at the same time, a new one popping up, which is called DPROD, Data Product Ontology, is literally one of the extremely well matching ontologies on the DKG because it allows productizing data. On top of that, I already mentioned uniform asset locators. They're like an extended URI. So they actually enable you to mint globally unique identifier that is ownable and transferable. So I can create one. Whenever I create a knowledge asset, I create another uniform asset locator, and nobody else can actually claim to own this identifier outside of me, while at the same time, I don't need to trust any other body to manage it. I can transfer it to Phil, for example, just by sending him this NFT. And the two of the best parts I left for the end. So the DKG pairnets, these are these topical knowledge graphs and associated services. I'll show another example in a bit, but one example you already saw, the Swiss Railways. That's basically a pairnet. They decided on a joint set of standards that they would use, such as the GS1 standards and schema.org vocabulary. And then they basically just started popping up these nodes without having to integrate one-to-one with anybody else. They're immediately part of a shared pairnet. That's a really, really important enabler because it removes all this complexity of one-to-one system integration. At the same time, it already starts at some base semantic level where everybody is agreed by joining this system. And then finally, the DREG framework, I mentioned, it enables actually querying these multitudes of these pairnets, which if you observe from the graph perspective, from kind of a just one node perspective, you will, they are basically main graphs. So you can think of different main graphs that you can query across different fields if that might need to be, needs to happen. And DREG framework allows you to do things such as, for example, intent matching. You see a question, you match it to a query you know, and then because that query is something that was tested previously, it won't hallucinate. It will just return the results that it sees in the knowledge graph. So again, just briefly on the pairnets, they're basically these, we call them pairnets, as they're parallel knowledge networks on the DKG, and they have shared ownership. So we here as a group, we could create the pairnet and we can have each one of our keys on the blockchain govern it, meaning we would own the infrastructure, the nodes, we would own the data, we would own the access control, and the governance decisions that we could make together, literally by voting on certain code updates. That's all part of this and already in production. And the cherry on top, which I believe is going to be very important in the very near future, is the human in the loop incentives. Basically, ability to incentivize growth of certain knowledge in a certain area. So, and not just the growth, but also the quality. So that basically there's a point system which actually relates to tokens that have value that you could use between or even internally in an organization to incentivize better publication of shared data products or knowledge assets in our world. Somebody mentioned open science. I have to show you a very short video of a SciGraph, which is a DSci-PairNet. Decentralized science is a very interesting area where basically this is an MVP of uploading a science paper, creating a simple knowledge asset from it, and publishing it into a PairNet, ultimately being able to query that through a DRAG interface and retrieving the answer from the knowledge graph using the Spark query. You'll also here see a visualization of this. So there's actually a very interesting community. There's a hackathon started today that will last for the next 2 months, where the global open source community will be building on top of this idea and the DKG for all kinds of uses in what they call decentralized science. And just 2 more examples. I promised the GS1 digital link one. You'll see also Emma, who is on the call in this GIF, basically accessing this is a real world productive example in Slovenia, where in the store you can actually scan poultry and dairy products and see all of the information coming from the supply chain transparently as a user by literally a chatbot like interface, which is actually a DRAG interface, queries knowledge graph under the hood. And finally, how this works is it basically reaches 2 million consumers daily in 20 countries, not just in Slovenia, but the Slovenian producer, who essentially use this today. So I'm sorry if I went a bit over time. This was it.
This is
and hope it was interesting.
No, this is fantastic stuff. Thank you. Yeah, I think maybe we should push forward. I'll do one question. I didn't see any others in the chat. While Christian gets poised. Did you see one, John?
No, but I'm just going to mention before we do start, we're pushed for time right now, but I want to mention something that Branimir mentioned that's really, really important for our next sessions and session 4 and 5 of this webinar. And Branimir talked about in building these distributed networks, you retain data ownership of it and privacy protection. And when we look at the governance of EUDR and EUDR solutions, this becomes an absolutely critical component. As Elizabeth mentioned earlier, organizations simply don't want to share information. And if they do share information, they want to know why it's used, who's using it, and is it being monetized? And could it be monetized for them? So there's a lot of relevant discussions. Phil is driving the digital link, which Branimir mentioned there peripherally, and it's a fantastic way because we don't have enough real estate on products to put all the labeling and all of the information. So you have that digital link, which will provide a landing page to get access to that information. So thanks again, Branimir, for a great overview. Brian, over to you.
I had a quick question around, so if we're going to mobilize the scientific evidence around sustainability, which we must do in various contexts in various ways, it seems that knowledge graphs are a powerful technology for being able to do that. However, the graphs themselves can get quite large, many millions or even billions of entities and relationships. And it seemed, and I love the decentralized architecture approach that you're taking, because it's kind of in that space somewhere where we can balance, general and specific. We can go deep, but we can also go broad. But a lot of the current research around that shows that it's quite easy to be breaking relationships and not adequately matching entities across. And so does your solution help with that, and how do you get around some of those alignment problems? And sorry, briefly, it's a complex question requiring a short answer.
Yeah, the easiest question. Yeah, no, it's thanks for the question. I believe you mentioned 2 things. One is the scale, and the other one is, okay, how to not get lost in that scale. So the first part of the scaling is where actually this decentralized infrastructure helps a lot, because if you start thinking from a decentralized perspective, you're immediately distributed. And that basically allows us, in a nutshell, to separate graphs in a sensible way, so that they can sustainably grow, so that none of the nodes in the network has to be massive in terms of hardware, for example. So a couple of things that happened here without going too much into the depth. Either a certain pairnet is hosted by multiple nodes, and then they shared, redistribute, basically shard this information, but also this big, the entire public DKG also does a sharding technique that enables effectively scaling it infinitely. Other elements there, people usually ask me, how does this scale with blockchain? Isn't blockchain something that doesn't scale that well? True and not so true, because the time is progressing, so we have better scalability there in terms of blockchains, but also when you use multiple blockchains, you can just keep adding more blockchains, so you have more space. When it comes to the semantic chaos, entropy that is caused by entity matching, essentially, that is not necessarily tackled by Origin Trail itself. It's more about pairnet builders. So I think I failed to mention that all these pairnets are essentially the way you would use the DKG. Any one of you here or any of the builders is you would just take it, you would instantiate your own pairnet, and then you would define the rules and how things would basically happen there. And then the DKG provides this infrastructure. So data provenance, the ownership, all of these capabilities are the layers that you get. But it doesn't natively help you solve that problem, though. What we are really interested in, and we will be actually, and this is the first time I mentioned, we will be publishing a call for papers, essentially, that will go into this direction, where we're looking for essentially knowledge graph embedding systems that would enable easy discovery of similar or exactly the same objects in a decentralized fashion. So this is something we're really excited about and looking forward to. But at the moment, Origin Trail by itself doesn't tackle this.
Yeah. It sounds like we're going to have to keep going, but it sounds like the real place to shine here is if we can have communities of domain experts, and then we've got a much easier kind of way to be managing the scalability and interoperability, where we can, leverage their expert depth and things representing that domain depth, and then we can pick some quite complex challenges, and we know what a sort of architecture of interoperable meaning would look like for that. Does that sound like a fair thing to say? It's very complimentary, so probably, yeah.
Yeah, it absolutely does. And not to take more time, I think there's this AI element where we obviously should not rely on it in depth, but it can vastly improve the space, because I believe one of the challenges of, I think most people would agree, of the knowledge graph space, it's just been too damn complex, and it's like you have to be an expert to do it.
That's right.
And now if we have the right approach with AI, it makes it easier. I mean, I know for myself, when I'm playing around with something, it just takes faster.
That's right. That's right.
It's going to scale.
It can help us wrangle the complexity. Absolutely. It's a matter of kind of methods and iteration, I think, to get there. And we can't just, as Phil mentioned, we can't just be feeding ChatGPT stuff and expecting it to help us manage the step. Actually, I think that might be just a great segue into Christian Hennig, and following our 14-minute rule, it would take us to the moment. I'm so sorry, Christian, but it's a great discussion, and I personally would like to stick around for a couple more minutes after. But thank you so much. Please, over to you.
Yeah, thank you, Brian. Thank you for the invitation. I think I will go more into the real world work, because we are a company that does system integrations for smaller companies, for small shareholders, for farmers. I think Federico is on board from Honduras. So our work is to make it work today, not tomorrow. So we have to take what is there and make it interoperable. And we bring our work into the ISO. So I'm the German chairman of the ISO TC347. I highly encourage anyone to contribute. Elizabeth, for instance, we are working on worldwide standards for data interoperability in the agri-food system. And my special part is AHG5, which is about AI readiness. I also have seen that Stuart Ria is on board, which leads AHG2 for agri-semantics. He's also a guy you should talk to. But now let me show you what we are doing in real life today. My approach on this, I don't think we will need ontologies or semantics in the future anymore. At least at the moment, we have 600 different ontologies and semantics in the agri-food sector. And as was pointed out before by Phil, nobody will drop them away and use something that works for all of us. So we need to make sure that we can talk to each other, at least the existing semantics, and we have to use AI because the climate change is not waiting. EU legislation is not waiting, so we have to stop do things the same way as we did in the pre-AI age. Because, in contrast to what Phil said, if we benchmark current AI systems, they have more agronomic knowledge than any of us. So the benchmark shows that they are very good if you provide them the information the right way. So my take on this is, it's not that you feed your data to ChatGPT and get the wrong answer. It's you feed your data the wrong way to the AI, and therefore you get the wrong answer. So it's very important to know how AI needs the information to make sense out of it. And if you look at the right on the time scale, what we expect, so we will have by 27, 28 in general artificial intelligence, which will self-optimize and that will get much more better than we are today. So we have to adopt to the AI age rather than to fight the AI age. And what the AI needs is she or he has all the knowledge in the world. It needs access to the real world context. So we have data out there that are in the real world that we need somehow to bring to a digital twin. And then we need to bring this digital twin to the AI. And the other way around, what we are also doing with our companies, by, for instance, steering robots, we need to get the conclusions, the workload back into a digital twin and then onto actuators. And as you may or may not know, there is a new connector between the AI world and our world called MCP, which is a model context protocol that was dropped as a standard by Anthropic in last autumn. And luckily enough, last week, OpenAI agreed to join the standard because those MCPs make it much easier for us to connect digital twins to the AI world. And that's why we generated something that is helping us. It's only helping us in a standardized ways to connect the real world to the AI world, which is called OpenRA, which means Open Regenerative Agriculture Language. And so for our customers, we are mapping existing semantics, ontologies, whatever they have. May it be a GS1 system, may it be a Siemens controller unit into OpenRA. And then we have MCP connectors that connect those to the existing artificial intelligence systems. So what is OpenRA? That's a maybe a little bit difficult question. So it's rather a small set of rules that if you follow those rules, let it be a ontology, let it be a JSON, whatever, that automatically generates interoperable digital twins by design and allows easy mapping from one to each other. What is quite different to anything that most ontologies, not all, Elizabeth showed examples of process-based ontologies too. We are strictly process-oriented. So any change in any object that you have, a digital object, must be made via a digitally signed or blockchain process. Those processes, and this is what I will show you in a minute, bring their own logic for execution. So they can have hard-coded bring your code or bring your prompt, even for AI processes that explain how a process has to be executed. That's quite new, I think, to the field. And all of those processes and objects must follow standardized or must contain standardized information. So most of this you can see maybe in ontologies too. So ontologies may follow those rules, but not all of them. That's one of the problems, yeah, that we have a high heterogeneity in ontology qualities. So we need a UID, we need linked objects like ontologies do with the attribution of roles, a process history, and so on. And what is most important is we need a definitions part. This is why most ontologies fail if you forward them to ontologies. They are ill described. So the AI doesn't understand the ontology per se, even it knows how our file works, because the definitions are missing or not accessible. So what we are using is any object, any process brings its definitions with it. And this makes it much easier for the AI to work with those information. And what the system also has to have, it must be accessible from the outside by a controlled authentication, accessible rights management, that you can work with those objects. In a matter of time, I will just skip those things, just showing you how a typical process looks like that brings its own prompt for a large language model. So you have input objects, output objects, a process, roles, linkage of the objects, and you have a description what happens inside the process. And we do a lot of stuff in many fields to help people generate a tracing of a food chain, of a water chain, of a wood chain, for instance. And all of those products are open RAL, and so they can communicate with each other. Just to give you one example, in the middle, this is EnviroDX app, which we generated for Blue Planet, which is helping people to trace what's happening in the water and what's happening if you treat water with bacteria, for instance, to cure them. And those are able to interact, for instance, with our robots or with field management systems. So this is something that we have real data interoperability on a small scale for our everyday work. And we are happy that we can contribute this now to Linux Foundation, XStack, as one way to have what is our vision in Android for the agri-food sector, that we have a data interoperability layer that anyone with any ontology, with any product can plug in and transfer data between them if the owners of the data agree to do this. And to give you some glimpses of what we do, so this is a project that we do in northern Germany, where we do an interconnected cheesemakery, where we connect, let's say, the biogas plant that has data about energy, the control of the climate that is done by an OPC UA interface, the cow manager software, a robot that fills in the yogurt, and direct distribution systems. And all of them can communicate because we are mapping all these different standards into our abstract interoperability standards. And I can already now tell you that we are, by doing this, saving 70% of energy in this project by just connecting those things and make it accessible for AI, that it can think about it. That's another one that shows you that German farmers, they can now use their soil samples and can forward them to a treatment planner that is AI powered. It has connections to web shops and consultants, and it's automatically, for one of our customers, generating a treatment plan that cures the soil with a filled shopping basket. And this is all done now automatically by linking and mapping the different information sources. And the reason that I'm here, the invitation by Brian, was that we also did this in the EUDR context for Honduran coffee farmers. It was a real challenge for us because most of them are farming outside of the internet. So we have a internet non-connectivity area, and then we have a food chain that starts in the Honduran mountains and ends at the EU border, where we have to check that under EUDR law there is deforestation-free graphic growing. So we had to find solutions to have a phone-to-phone transmission of the data, and then we had to trace the complete chain into the mills, and then we had to generate a DDR at the European border. And to do this, we had to link information about the deforestation state, the field boundaries, the farmer identification, the legal frameworks of the USA, the transport tracking, and a digital signage solution that works offline for this project. And what came out, Federico is here, maybe he is in the middle of the image. You can see he can tell us about his experience. We set up an OpenRAL infrastructure for this project. You can see there are only few processes. I told you that we are process oriented. So each object, so each coffee, each container starts with the generate digital sibling process. Then we have only a few processes that are happening: change container, change owner, aggregate items, and generate DDS. And we only had to include one data source, which is the WISP API from FAO to connect the field boundary information with the satellite data to get the deforestation information. So this was a really fun project, where we are happy to help people. And we had also some challenges. As I said, we had to transmit data without the internet from peer to peer. And we solved this by high-speed QR movies that can be transmitted between phones and phones. They are digitally signed, so we can always make sure that the two partners really agreed to trade the coffee. And we transmit all the information to the next peer until we have contact to the internet, where we then sync it to the cloud. And we made this accessible in 4 languages to date, as an Android, iPhone web app. And if you want to look at how we are doing this, you can look at the Linux Foundation repository, because this is also open source as part of the X stack. I think I made it in time, I would say.
Thank you so much, Christian, for that. Before Brian does the final closing, I want to thank Phil before he leaves, also Elizabeth, Branimir, and Christian for an incredible set of lenses on this complex topic of interoperability. We still have over 40 people in the group, which is great. For those of you wondering, we will be sharing the information afterwards. If you do have any questions or comments, please feel free to come in to Brian and I. Brian, over to you for the closing.
I think if folks are okay with it, and we understand that people have hard stops, but those of us who are still here, we could discuss for a few minutes, and we'll be sharing the recording around if that's okay with you. Give me some thumbs ups if that's okay. I'll just be looking for thumbs ups. I see a hand coming. That's an encouraging signal. Yeah. Let's see. So yeah, let's do a couple of questions. And I see there's so who was it that raised a hand? Or maybe that was a thumbs up hand raised.
Mistaken thumbs up, yeah.
Or a mistaken thumbs up, yeah. So really, first of all, just reactions across those of the speakers that we've. I know Phil has to drop, but some reactions, folks. Kind of on each other's contributions, really. I think, there seem to be some through lines regarding, well, certainly use of semantics at some level, certainly managing meaning, as close to the use as can be, but the uses themselves are quite varied. And there's this overarching, problem around kind of using human knowledge and knowledge representation for sustainability, that I'm sure we all agree we've not really solved yet, although we're on some good tracks, I think, with the what we heard today. So I'd love to hear some reactions across from you all, really, about each other's presentations.
Branimir, why didn't you start?
Yeah, I raised my hand, so why not? Yeah, very exciting event altogether. I guess Christian's presentation was the last one. It's the most fresh in my mind, and I really enjoyed also the opinionation that we won't need ontologies in the future. I'm not sure I agree, but I very much like the futuristic thinking and subscribe to it. And yeah, I think overall, I love seeing solutions like that actually being applied, because there's once you get in contact with the real world and actually building something in production or even POC, you then run into many more problems than you normally would think you would. So the complexity of the real world needs to be tamed, and And something like OpenRAL sounds very exciting. I haven't heard about it before, so I would dive definitely deeper into it. And perhaps a question on that, you mentioned some form of blockchain interoperability angle there, if I understood. Christian, could you perhaps elaborate on that? Because the way I understood, a function or an operation could be somehow digitally signed and interacting with the blockchain?
Yeah, so for the Honduras project, we didn't use blockchain. We could have used, so we thought about at the beginning a hyperledger and something like this, but we had to use a very technically simple solution that works in Honduras. So in this case, we just used private and public keys. So at each device, we store a private key, and the public key is then sent to the trusted central cloud for Honduras. And so each partner for each process is signing its part, and then it's uploaded, and it's only accepted in the cloud if the digital keys are working correctly. That's what you will also see in the source code. But however, you could also imagine in another setup where you could replace the simple signage process with a more decentralized way, that we could replace this also by a blockchain approach, which I would personally prefer.
Because I was seeing that at a kind of architecture level, how we manage the interoperability in terms of linking up linking up schemas, linking up systems in a very applied way around a particular set of questions. But then there's this whole decentralized architecture set of questions that we need to kind of examine the right sort of relationship with. I think that's great. And I hadn't really thought about blockchain for that, but obviously there are strengths to that technology that we can leverage, and we can delve into the sort of decentralization of meaning questions on another call. But before we lose Elizabeth, I wanted to hear her observations about where what we might call more formal knowledge representation where we have to have domain experts, such as around open science questions, kind of where some of that things could be enriched in the approaches we've heard. What do you think, Elizabeth?
Yeah.
Oh, and you have to leave in it's all right, in 1 minute.
In 2 minutes,
but,
yeah. I have an appointment at 6, unfortunately.
Oh, yeah, sorry.
Yeah. I think that all we discussed today reflect the needs in common to many projects working on food supply chains in terms of data interoperability and transparency. It's a societal need, I think. What I understood, everything is all the presentation were interconnected. And it's very interesting to see that, because from the use of semantics to the use of standards and some solution to tracking the origin, I'm also, I think it's where we need some expert effort. It's to really make sure that the representation of the human knowledge in some of the area that are important for the supply chain are fulfilled, because there are still gaps, I think, and even if there are some vocabularies existing, they may be very community-based, so we need something more global. And I think also a point you made, Christian, is about using AI and not doing things as it was before AI. We could also promote the use of AI to develop the vocabulary, the ontologies, with some human supervision, but it's already an effort that is going on in the Obo Foundry community. It's to use a suite of tools called Dragon AI, and to develop those ontologies, it's quite nice, but still need human supervision in the definition and check of the context of use. So this could be something to look at to speed up the process to complement the vocabulary needed along the supply chain, I would say. The other thing I just wanted to highlight from your your discussion, I put a comment on it. It's of course all supply chains have to show low impact on the environment. So, and this is a very large set of criteria, which makes the information very difficult to store, to know if the food product is really harmless for the environment. And one thing is seems to be rising is the need to have some data about the regenerative agriculture, as you said. The periodic table of food is really making a big effort to develop metadata schema about the food sample, where it has been collected, how it was produced, and the production way is very important because they would like to understand if, for example, organic production or regenerative agriculture may have also an impact on the nutritional value of the food product. So there are very interesting connections to do, even beyond just managing a food supply chain and tracking the origin. It's also to understand the impact on the nutritional value of the food. So that's also, and in terms of governance, I think it's also a very important topic. It's to understand how the data can be made open without harm, making some, I would say, breach into the legal aspect of GDPR, and also avoiding to create a competitive environment to people developing solutions. So that's the elements I just wanted to highlight. And for sure, the semantics is a cornerstone of all that, for sure. I'm sorry, I'm a bit in a rush.
Yeah, no, of course. Yeah, thank you. That's on us. But it's a provocative statement from Christian that we can put in our context, I'm sure. But but in terms of governance and in terms of domain depth, and then the kind of two-way relationship between AI tools and, you know, kind of what's been pretty sort of formal knowledge representation obviously is there. And so it's not an either or proposition either. So I think we should probably wrap up now. We're 10 minutes over, and we're performing for the video now. While we still have 29 people on the line, plus the Bubbles note taker. So I think we should probably wrap up now, and we'll circulate around the decks and the video, and the links to the various GitHubs will also be available. So yeah, any closing thoughts? Yeah, thank you so much, everybody.
Thank you to everyone for staying with us. And as usual, the speakers we already thanked. For those of you who are listening and want to get more information, please come into Brian or I, or directly into one of the speakers. This is all about you. Also, keep an eye out for the next 4 sessions. We're going to skip next week, and then we're going to have 4 sessions, one every week, up to the 13th of May. Thank you all so much. Have a great rest of the day. Have a great rest of the evening and a week. All the best.
Bye-bye. Bye for now.